Feb March 17, paper 42. In this question, we have a rocket launching away from the surface of a planet. We're going to look at the changes in energy again. So if you haven't tried the question, try it first lah. Give it a try, come back and watch the discussion. So it starts off by asking you to define what is defined many times, which is gravitational potential, right? So this is work done, okay? So whenever I see this as a student, I will make sure I write it as a practice because this one is somewhat memory work, okay? So work done in bringing a unit mass. So the term unit mass have to be there. I'm just going to underline this. Work done per unit mass, or work done in bringing a unit mass. This is B1. Actually, I think this is M1. Sorry. M1 meaning you must score this mark before you can score the next mark. So work done in bringing a unit mass, or per unit mass, from infinity to this point, a point, right? To a point in the gravitational field. So the next mark will be from infinity to a point. This is A1. You can only get your A1 mark if you score your M1 mark. Because think about it, from infinity to a point in a gravitational field sort of makes no sense, right? Okay, so that's why they are quite strict with definition, as they should be, because this is a scientific understanding that definitions are mutually agreed upon. Anyway, let's move on to part B. So in this question, it's a derivation question. Okay, a rocket is launched from the surface of a planet and move along a radial path. So a radial path is a path that passes through the radius lah. I'll give you a non-radial path now. This is a non-radial path. Okay, this one non-radial, all these non-radial, so must pass through the radius. Okay, the planet may be considered an isolated sphere with radius r. Okay, it has marked out the radius for me, that's great. With all of its mass m concentrated at the center. Yes, standard stuff. If not, you cannot use Newton's law of gravitation as it is. Point A is a distance r from the surface, and point B is 4r from the surface. Okay, so it's a good thing that they draw for us, okay? Because if let's say they didn't draw, they just give you these statements, you may actually forgotten that this r is from surface, and then this is from surface. Meaning later when we find distance, you better, let's hope that everyone remembers to add this r into all our values, because A is actually 2r and B is actually a distance 5r. Deception. Traps. Okay, I'm gonna write here big so we don't fall into that trap. Put a signboard. Okay, so we're all measuring the distance from the surface, which is not how we substitute into the equation. Sigh. Anyway, part 1, show the difference in gravitational potential between point A's and point B's given by this expression, where G is the gravitational constant. Okay, hold on to your horses first. When you see this kind of thing, first thing you do is you write the equation. Write your insurance plan, negative Gm over R. Okay, and we are going to take A and B. So they just want difference in gravitational potential. So in this case, the magnitude matters. We don't really care whether increase or decrease lah. Well, it really depends lah. If you move from A to B, potential increase. You move from B to A, potential decrease. And they didn't even say, they just say the difference between these 2 points. Okay, so I'm just going to take the difference in potential as potential in A minus potential in B. Okay, so very quickly, this is negative Gm. The distance of A, okay, distance of A is 2r. A lot of people will write r. From my experience, I may have written r also. Okay, anyway, the other one will be Gm over 5r. So distance from here to here is 5r, 2r. All right, let's factorize the common factors. So this will be Gm over r. In the bracket, negative is positive, 1 over 5 minus 1 over 2. Means I get negative now. Never mind. It doesn't matter. Okay, so if I take 1 over 5 minus 1 over 2, I believe I will get 3 over 10. Right? Let me try. Or negative 3 over 10. Yes. Okay, so how to explain away the negative? You can just say, you don't have to explain, so just say that you accidentally taken the smaller value minus the bigger value, or you can just put a modulus here. So you want to save yourself some headache, you can put a modulus here. Not needed. For physics, this is not math, so you can just say, hence, the change in potential is equal to 3 over 10 gm over r. This one, you can put magnitude only. Okay, so we're not talking about whether the change is increase or decrease, because we don't know. So where is the mark? Because this is 1 mark. We see this is the mark. So we are assuming that you can minus lah. So if let's say we measure the wrong distance, you will not get 3 over 10, and then you will adjust accordingly. So think about the similar questions that you have done. Whenever we are trying to find the change in potential or the change in potential energy between 2 points, it's important to minus them and be a bit careful about the sign. All right. Okay, that's all for this one. We're going to carry on to the next part of the question. This question is only 6 marks. Okay. So anyway, our rocket motor is switched off at point A during the journey from A to B. Oh no, is it a malfunction? Are we going to die? Kidnapped by aliens? Anyway, the rocket has a constant mass of this much, pretty light rocket, and the kinetic energy changes from 1.7 terajoule to 0.88 terajoule. Okay. For the planet, the product GM, wow, this one is so another high level. Instead of giving you the mass of the planet, they multiply the gravitational constant and the mass of the planet for you already. Nice. It may be assumed that resistive forces are negligible. Yay, no friction. Use the expression in B1 to determine the distance from A to B. Okay, a lot of things to brain. I think we draw a picture. Okay, so I'm going to import the picture over to discuss. Okay, so I have cropped another picture of the same picture that's given in the question. Okay, and now we are moving from A to B. Okay, lie. Where is A? A is here. We're going to travel our little rocket ship. Is my drawing okay? Do not, I always lose in the scribble.io stuff. Okay, so we don't know the speed, but we do know the kinetic energy. And because the kinetic energy changes from 1.7 to 0.88 terajoule, I know the speed decreases lah, okay? So this is 1.70 terajoule, 0.88 terajoule. Okay, so I draw a shorter arrow. What does motor switch off at point A mean? Whenever we switch off a motor, it tells us that we are not adding extra energy into the system. So no added energy to the rocket. So whatever energy the rocket has at point A, the total energy will stay the same. On the right here. Total energy constant. So if it loses kinetic energy, it has to be converted to potential energy because the resistive forces is negligible. I think we can at least start by writing a conservation of energy. So I will write here, from A to B, the decrease in kinetic energy is equal to the increase in gravitational potential energy. It's traveling from A to B, so the further away from the center, less negative. You think about your graph like that. A is probably here, B is probably here. You are moving up the potential gradient. So your potential energy increases. Okay, so here we will take the value, which is 1.7 minus 0.88. 1.70 minus 0.88 terajoule. Just going to put TJ here. Junior terajoule. Increase in GPE. So I will take the potential energy. Well, where is it higher? B, right? At B minus the potential energy at A. Okay? So I just want the numbers, the magnitude. So I'll take the larger number minus the smaller number lah. I don't have any, I mean, I could calculate starting from scratch, but I actually did some work before. And the question actually tried to say, use the expression in B1. Okay, so then I can actually change this to M, because this is M potential in B minus M potential in A, where M here is the mass of the rocket. All right, so a recap, potential is potential energy per unit mass. So I'm using this one. All right, so I can continue already. So I'll just settle this 1.7 minus 0.88 first. Ding ding, that would be 0.82 tera. Tera is 10 to the power of what? Terabytes. So if you forget, then you can go 10 to the power of 6 is megabyte. We always go 6, 9, 12. Gigabyte, terabyte times 10 to the power of 12. Okay? And this will be mass of the rocket. And find this as the change. I mean, I'll not skip step, okay? Potential in B minus potential in A, which is also equal to M, the change in potential for AB, which we already have an expression for previously. So I'm going to steal the expression from here. Ding, ding, ding. This one. Change in potential from A to B. A, see, we took A minus B one. So A minus B, B minus A, the difference will be the same. I'll just take the magnitude, 3 over 10 GM over R. So I'll continue this. This will be M, 3 over 10 GM over R. Okay, before we get too excited, let's remind ourselves again. This is cannot M square. This is the mass of rocket. Okay, I'm going to use green highlight. This is mass of rocket. Mass of rocket, mass of rocket, mass of rocket. What about this M? This GM is the planet's GM. Okay, this one. So they are trying to do this to prevent you from substituting the wrong mass or power 2 and then you get lost. Miss, they give me GM. What to do? I got GM square. Okay, you chill. Okay, so this GM is for the planet. Planet is GM. Rocket is small m. Okay, I'm sorry, my capital M and small m kind of look the same, but they're not really the same too. So this one is the planet. Right? Okay, so I guess we could substitute now. On one hand, I have 0.82 times 10 to the power of 12. This mass is mass of the rocket. Let us go and find. The mass of the rocket is 4.7 times 10 to the power of 4. So I'll put this here. 4.7 times 10 to the power of 4. Bracket. 3 over 10. We have GM, right? GM here is 4.0 times 10 to the power of 14. So put that in. 4.0 times 10 to the power of 14. Divided by R. We are looking for R, right? Let's check on the question. It says here, determine the distance from A to B. Where is A to B, my friends? A to B is here. And A to B is 3R. If I can find R, I can find 3R. So we are looking for distance. Okay, so I can continue this to find r. I can press calculator already. So I'll show you how to press. Okay, so I'll start with whatever I have on the left. 0.82 times 10 to the power of 12. I'll start mentally moving things over. If you cannot do that, you may need to write a bit more. Okay, so I divide by this one. Multiply by 10. Divide by 3. Divide by 4.0 times 10 to the power of 14. This is 1 over r. Okay, so then I 1 over answer. So we get 6.88. Okay, pro tip. You could move the decimal point or you could press ENG. It says ENG button, ENG, engineering. So 6.88 times 10 to the power of 6. That will be my r. 6.88 times 10 to the power of 6. Okay, so now we can find AB. Hence, the distance AB is equal to 3r, which will be equal to 6.88 times 10 to the power of 6. Ding, ding, ding. Then you take out a calculator. Learn to press lah. I come from a generation, because I'm quite old actually. I come from a generation where scientific calculator was not used. How did I survive? I learned to use a normal calculator. Okay, anyway, this one would be 20.6 times 10 to the power of 6. I guess 2.06 times 10 to the power of 7. Can do it one. So 2.1 times 10 to the power of 7 if you want to write it in 2SF. Okay, so this one is a little bit longer than usual. Okay, so what did I do? First step, whenever something is hard, whenever you do questions and it's hard, but I got to the answer, don't immediately just take a half an hour break lah. Your brain is trying to digest. So help your brain out by reviewing the question again. We understand that the motor is switched off, so there's no added energy. So the rocket is going to travel from A to B. And it's pretty obvious the rocket is slowing down because the kinetic energy is decreasing. If the rocket is slowing down, the energy has to convert to something else. Since there's no friction, the energy will be converted to potential energy. That's why I can say decrease in kinetic energy is increase in GPE. The question is asking us to determine the distance from A to B. So the tricky part about this question is the distances. They measure distances and then you find r, you think you can end the question already, but actually no, you have to multiply by 3. So it'll be a bit sad to lose that mark because you've forgotten to multiply by 3. Yeah? Alright, so we start with decrease in kinetic energy, 1.7, 0.88. So the kinetic energy section is easy to negotiate. You can just leave it there. Whereas the increase in GPE needs a little bit of care. So I will take the potential energy, the large potential energy, minus the smaller potential energy. Because I know the further away you are, the greater your potential energy. Okay, so it doesn't, B has a larger potential energy, but it doesn't matter because you can just take the magnitude. So I know potential energy, and potential is related by the fact that potential is potential energy per unit mass. So I plug it in. Potential energy of B is mass of the rocket times potential of the rocket at B, potential energy at A, mass of the rocket times potential of the rocket at A. After that, what do? I factorize M, and I'm very careful to remind myself all this M is mass of the rocket, because I don't want to confuse myself between the mass of the rocket and the mass of the planet. When it comes to planet, it is stuck to potential. You know why? Because potential is determined by the gravitational field of the planet. All right, so I will need to find the potential at B minus the potential at A. Good news, I've already found it in the previous section, or they've given it to me and I can use it now. All right, so that will be 3 over 10 GM over R. The question tried to help you a bit, but instead of giving you the mass, they gave you GM, so that you won't confuse this mass of the rocket and this blue color mass of the planet. But you'll be surprised lah, okay? So make sure that it's very clear. You know when you write that M, what that M represents. Is it rocket? Is it planet? So then after that, it's just substitution. If you can just directly use your calculator to key in as I showed you just now. If not, it's okay, it's fine. Take your time to slowly move things over to find your R, but not too much time lah, okay? Please don't spend half an hour in one question. All right, then after that, we have r. The distance AB is 3r. We can get this value. So where are our 3 marks? The first mark is when you find the change in GPE correctly. So we see the change in GPE as something like this lah. This one here. This one is C1. Here, and substitute correctly. This is all C1. Okay, and then you equate this to kinetic energy. I'm going to change color. Equate this to kinetic energy, and then find R. This is C1. And once you arrive at this 6.88, you will get 2 marks already. But you will only get the third mark if you find the distance AB, which is 3R. Hopefully that makes sense. Okay, so that will be AB is 3R. You multiply by this, you get the answer. That will be A1. 2.1 times 10 to the power of 7. So this question is not as easy as you think. Pretty hard one. But if you can do it, good job. All right. So at the end of the day, we are just looking at something that's very familiar. Imagine a trolley running away from A to B. So if you think about this potential gradient as an inclined plane, the trolley is going from A to B. Trolley will slow down because the trolley has no motor. We turn off the motor already. Trolley will slow down. This is analogy. Trolley will slow down, but it's going higher on the ramp. That means the potential energy will increase. So the change in potential energy is a change in kinetic energy, thanks to conservation of energy. So based on the changes of the energy of the rocket and a little bit slightly more complicated than usual potential energy calculation, you can find whatever value they want you to find, whether it's distances or mass of the rocket or speed of the rocket. Okay, that's it for this beautiful Feb March 17 paper 42.